Okay, let's look at multiplying and dividing by 10, 100 and 1000. So normally when you multiply something like this, you will need to do something like the standard method, and this takes a little while, doesn't it? Or the grid method, as you can see in the other videos. This takes a while to do. I'm rushing it and doing it quickly, but that's the method we would normally do if we are doing multiplication. But when it comes to special numbers, you don't actually have to do that anymore. When you see certain numbers, and those numbers are ones with a 0 on the end, 10, 100 or 1000, you don't have to do a long method. You don't have to do the standard method anymore. It's easier than that, isn't it? So when you're multiplying things by 10, like 3.6 times 10, I just do a little times 10. 3.6 times 10, all you have to do is line up your decimal point, move everything one place bigger, because times makes things bigger usually, doesn't it? So 3.6 times 10, I call this the moving method. Everything's moved one place bigger. You can see how the 3 is moved one place bigger. Let's do another one. Say it was 4.852. If you're going to multiply that by 10, 4.852 times 10, I'm not going to do a method. All I'm doing is copying the number out underneath. I'm going to move everything one place bigger. Times 10 makes things one place bigger. 48.52. So 568 times 10. If there's no decimal point, I put one on the end. Make everything one place bigger. I know you're probably thinking, oh, you just add a 0, you just add a 0. And on this one, it's true, you just place a 0, don't you? But it doesn't always work with more difficult numbers with decimals. So 568 times 10 is 5,680. One place bigger. Let's do 4.273. This time times 100. Now, times 100 is not the same as times 10. Times 100, 100 has 2 zeros. Everything moves 2 places bigger. Line up the point. The 4 does not go underneath. It goes 1, 2 places bigger. The 2, it goes 1, 2 places bigger. The 7 goes 1, 2 places bigger. And the 3 goes 2 places bigger. It still is 4273. 4273. The order doesn't change. Everything's just moved 2 places bigger. So 4 times 100 would be 400. 4.273 times 100 is 427.3. And let's finally look at something such as 36.7 times 1000. You cannot just place 3 zeros on this one, it won't work. You have to line up the decimal point and you move it 3 places bigger. 1, 2, 3. 3 goes right over here. 3, 6, 7. If you get spaces like this before the decimal point, you're going to have to place zeros there. I always just check, did everything get 3 places bigger with the 3? 1, 2, 3, yeah. 3, 6, 7 is the order, and in the answer it's the order. So 36.7 times 1000 is 36,700. Let's look at dividing by 10, 100 and 1000. So 36 divided by 10. Right, 36, there's no decimal point, so I put one on the end. Line up the decimal point underneath. Now divide makes things smaller usually. Divided by 10 is one place smaller, we get 3.6. I call it the moving method because we've moved it one place smaller. Let's do 4.89 dividing it by 100. Divided makes things smaller, so make sure we move it goes to the right towards the decimal end of things where things get smaller. Divided by 100 is 2 places smaller because there's 2 zeros on 100. 4 goes right over here. 489, still 489, but we're going to need to place some zeros. 0.0489. And finally, let's do 5 divided by 1000. 5 doesn't have a decimal place on it, so I'll put one on the end. Put one underneath. 5 is going to have to get 3 places smaller. 3 zeros on 1000, so move 3 places smaller. 1, 2, 3. 5 goes right over here. I always check at the end. That doesn't look right to me, is that right? 1, 2, 3 places smaller, yeah. It is right, 0.005. I've been doing things like 5.6 times 100, okay? And I'll move it 2 places bigger. 1, 2, 5, 6, 0 is 560. But just remember as well, if you got the question 100 times 5.6, It doesn't matter which number comes first in time, so you can switch them round. So I would switch them round, and I would actually do 5.6. I would actually do 5.6 times 100. So I'd do 5.6 like this, 2 places bigger, and you get 560. So 5.6 is 5.6 times 100 is the same as 100 times 5.6. You can do it either way.
I'm sure many of you are interested to know what the naughty decimal method is. It's naughty for a couple of reasons. The first reason is that, it's just naughty for just that one reason. And the one reason is that when you're multiplying and dividing by 10,000, you're not moving the decimal point. And that's very, very important. You're not moving the decimal point. You're moving the numbers into different place values as a result of the number being multiplied or divided. So, for example, just to quickly reiterate, if you've got 75 times 100, now we don't need to do the naughty decimal method with this one. You've got 75 and you've got 2 zeros. Now, we're not just adding the zeros. We're using these zeros to increase the place values of these numbers. Now, if there's 2 zeros in the number is increasing by 2 place values. So that number that was originally 5 is now a 500 as a result of it being multiplied by 100. Now, in this method, it's a very naughty method, like I said, it's because you're moving decimals to get the right answer, when actually that doesn't really happen. Conceptually, that's not correct. But we're going to show you the way anyway, just in case. You might find this an easier way to do it. To
be honest, Mr. Blom, a lot of children always try and do it this way anyway.
Yeah.
So we might as well show them how to do it properly.
Yeah, exactly. Let's have a look. 6.5. You write down 6.5. You're multiplying by 10, which means you're moving it 1 place value, which means the decimal point will move 1 place value. It is moving to the right or to the left. Well, is the number getting bigger or smaller? The number is getting bigger, so the decimal point needs to move to the right. Therefore, the answer is 65. 4.85, let's write that over here. I'm going to write it smaller so I can fit everything in. 4.85 times 1,000. 1,000 has 1, 2, 3 zeros, which means the decimal point is going to be moved 3 times. We go 1, 2, 3. Now, I always call these jumps tunnels, because there should always be a train in every tunnel. There should always be a value in every tunnel. So in this tunnel over here, we've got an 8, we've got a 5 in this tunnel over here. But in this tunnel, we don't have a value, which means that the place value is going to be incorrect if I don't put a placeholder in there. So what I've done is I put a placeholder in there, which makes my answer 4850. 6 divided by 100. You're doing the exact same thing, apart from the fact that you're going to move the decimal in the opposite direction as a result of the number getting smaller. So we start with 6. Now, units are always at the end with a decimal point. If you know the decimal points at the end of a unit, then you'll be absolutely fine, because then you'll be able to move it. We're going to now move the number to the left-hand side. How many zeros do we have in 100? 1, 2. So we move it twice. 1, 2, decimal point. The trains are not in the tunnels. We need to make sure we put the 0 there. There always needs to be a value present when there is a unit. So we need to put the 0 in there. So the answer is 0.06.